Hello viewers, in this tutorial we will continue with equilibrium and related problem solving pertaining to non-concurrent force system. Of course, this is the continuation of tutorial number 3 wherein we understood the types of supports, the types of loads, and how exactly certain types of loads are to be represented like UDL, UVL, etc., and how can we find out the reactions. The gist of the matter is, while finding unknowns in a non-concurrent force system that is in equilibrium, we have to press three equations into service. Number 1, sigma fx equal to 0. Number 2, sigma fy equal to 0. Number 3, sigma m equal to 0. Algebraic sum of moments with respect to some point should be equal to 0. Algebraic sum of horizontal forces should be equal to 0. Algebraic sum of vertical forces must be equal to 0. So with this knowledge, we will continue with tutorial number 4 and we will just continue to solve problems of various interest, particularly of engineering interest. Now, the beam has a uniform weight of 500 Newton per meter length of the beam. Determine the reactions at the supports. The beam is like this, and it has a span of 2.4 plus 1.2, that is 3.6, and there is a box that is being loaded with 300 kg. Now we need to convert these forces into either Newton or kilonewton. And if we write the equivalent system of the beam, here it is. Exactly at 1.8 meters there is the weight acting, the weight of the beam acting, and this is the weight of the box, and we will just compute that total weight of the beam is 500 newtons per meter. Therefore it is 500 into 3.6. it becomes 1800 newton or 1.8 kilonewton. It acts exactly at the center. And on the other hand, weight of the box is given to be 300 kg. Of course, 1 kg equal to 10 newtons, and perfectly speaking or precisely speaking, 1 kg should be equal to 9.8 newton. Anyway, we will just take the approximate value to the nearest integer, so it becomes 10. So 300 into 10 is 3000 newton, and it becomes 3 kilonewton. Now the beam is reduced to two concentrated loads acting at different places, one at 1.2 meters, the other one exactly at the center of the beam. Now we need to find out vertical reaction at A and vertical reaction at B. Here horizontal reaction never surface even at the hinge because there are no horizontal forces applied over the beam. Now sigma Fy equal to 0 will give us VA going up, VB going up, both of them are positive, equal to one force, that is the total weight coming down, that is 1.8 kilonewton, and plus 3 kilonewton, the weight of the box. Anyway, we have not solved the unknowns. We have two unknowns. One of the equations we have already used. Therefore, the remaining equation is sigma m with respect to some point should be equal to 0. We'll take sigma ma equal to 0. That means the moment of all the forces, algebraic sum of all the forces, moment of all the forces with respect to this particular point should be equal to 0. So in order to expect the moment of this particular beam, we need to release the support over here. As soon as we release the support, we should apply the vertical reaction over here, and this vertical reaction will have a negative effect because it is anti-clockwise. WVB into 3.6 equal to 1.8 into 1.8. This is clockwise, and 3 into 2.4. Because the total distance is 3.6 minus 1.2, that becomes 2.4. So the total moment should be equal to 10.44, and that's how we will calculate VB, and VB happens to be 2.9 kilonewton going up because the value answer is positive. And using the equation 1 that we wrote when we wrote sigma Fy equal to 0, we can compute the value of VA. VA happens to be 4.8 minus 2.9, that is 1.9 kilonewton. That's how we compute. And in this particular problem, we have just used sigma moment equal to 0 and sum of the vertical forces equal to 0. Now we will look into the other problem. A 5 kilonewton cantilever that is the total weight of the cantilever is 5 kilonewton. Beam is subjected to loads as shown. Determine the reaction at the fixed support. As we know, a cantilever beam will have only one support, that is the fixed support. At the fixed support, and this has the components, horizontal component and vertical component, and the fixed support will have a vertical reaction going up, and this is our assumption anyway, and the horizontal reaction going to the right. That is, we will assume positive reactions here and a positive momentum. And we know from the from third tutorial that a fixed support will have three unknowns, and degree of freedom equal to 0, and we will just apply the loads, and we have three unknowns over here. Therefore we need to apply all the three fundamental equations of statics. Sigma fx equal to 0 will give us HO, horizontal force acting rightwards, minus 3 sine 30. Angle is referred with respect to vertical, therefore the horizontal component will be 3 sine 30. It is negative because this component is going leftwards, therefore H naught equal to 1.5 kilonewtons. So one of the unknowns is out. Sigma mo equal to 0. We will take moment of all the forces with respect to this particular point to be equal to 0, and we should always remember that the reaction should also be included, as we included vertical reactions, as we included horizontal reaction when we wrote down sigma fx equal to 0 or sigma fy equal to 0. So it is 3 cos 30, the vertical component, into momentum, the entire length of the beam. It is 1.8, 1.8, 3.6 plus 1.2, that is 4.8. It is clockwise. Minus 15, it's a readily available concentrated moment which is already given to be anti-clockwise, therefore it is minus 15. Plus 5, the weight of the beam acting exactly at the center, 5 plus 5 into 2.4, that is also clockwise moment. Minus 1.4, there is a force which is going up, okay, contrary to our expectations, but anyway, this situation must have demanded a force which is going up. Usually beams are applied with the loads which are going down. So 1.4 into 1.2, this is the momentum and this is the vertical force. It will also generate a anti-clockwise moment, therefore it comes with a negative sign, plus m, the reaction, moment reaction that we have assumed over here, and we have assumed it to be positive, therefore we have denoted it to be positive. Upon simplification we will get m equal to minus 7.8 kilonewton meter. That means the assumed direction of this particular moment is wrong, therefore we will just change it later. So sigma fy equal to 0, so v naught, that is v0 going up, plus 1.4, that is also going up, minus 5, rest of the forces are negative, 3 cos 30, so it will give us VO equal to 6.2 kilonewton. So we will just change that the direction of that, otherwise it will become wrong on our part. So it should be like this. Yeah, everything we have found out, and we should change the directionality of this moment reaction because it is giving us minus value. So our assumption was wrong. The weight of the bicycle is 400 Newton. This is the third problem. Determine the normal reactions at A and B when the bicycle is in equilibrium. So it is standing like this, standstill, and here is the weight, and this happens to be the center of gravity of the cycle, and the weight of the cycle is 400 Newton, approximately 40 kg, and this is the touch it is giving to the road surface, and this is the contact it is giving to the road surface, and we need to draw a tangent. Since roads are horizontal or plane and horizontal, the reactions will be vertical, therefore we will have vertical reaction at B like this and vertical reaction at A like this. And here also we need to find out only vertical reactions, horizontal reaction is absent, so it is good enough if we apply only two equations. Let us see. Now sigma ma equal to 0, so VB into 1.1, VB into 1.1, 0.6 plus 0.5, which can lift the bicycle in anti-clockwise direction. It can rotate. 400 into 0.5, the load, the total load of the beam, and the total weight of the bicycle. So 400 into 0.5. Those two are the only two forces, one unknown and one weight. So it will give us VB equal to 200 divided by 1.1. That will give us 181.8 Newton. And sigma Fy equal to 0 will give us VA plus VB equal to 400, the total weight. Therefore VA equal to 400 minus 181.8, and we will get 218.2. so 21.8 over here and 181.8 over here. So a 10 kilonewton weight cantilever steel beam is supported and loaded with 10 kilonewton as shown. Find reactions at hinged support. What is the resultant reaction at A? So here there is a wire that is being tied to the wall, and definitely, and there is a weight that is being attached through a hook, and here it is a hinged support, and it is given to be cantilever, and it has a weight of 10 kilonewton which act exactly at the center. Now 10 kilonewton will be over here, and this is the tension, and we need to cut it over here to write the free body diagram. And here there is an horizontal force HA, and we have assumed this way. We could have assumed in the other direction also, but anyway, the final answer would have given the true sign of HA, and VA is vertical, that we have assumed, and the resultant of HA and VA happens to be the resultant going like this, which is shown in black arrow. Now we will just use we need to use once again two equations in order to determine the unknown. Yeah, it's here. We have taken it to different screen, and now we will apply sigma fx equal to 0. Sigma fx equal to minus HA T cos 30. So tension, this is tension in the wire, it's acting like this in this direction. T cos 30 is the horizontal component, so T cos 30 minus HA equal to 0. So HA equal to 0.887T. So our assumed direction is correct because HA is coming out to be positive. Now we will apply sigma MA equal to 0, and we will see what happens. So T sin 30, which is going vertically up, and it's actually acting over here. It's acting actually over here. It is 3 meters given. So T sin 30 into 3, which is clockwise bending moment, clockwise moment, minus 10 into 1.2. This is the applied load into 1.2, that is anti-clockwise in nature, minus 10 into 2. Minus 10, this is the total weight of the beam acting at the center of the beam. It is 2 meters, so minus 10 into 2. So this is anti-clockwise, this is also anti-clockwise. The clockwise moment is given by tension, the two vertical component of tension. Upon simplifying this, we get T equal to 21.33 kilonewton. Now we can find out what is HA. That is HA is 0.87 into T. It emerges to be 18.55. And continuing with this, sigma Fy equal to 0, we have VA that's going up. This is our assumed direction, minus 10 the weight, minus 10 the applied load. We have got VA equal to 20 kilonewton. So all the answers are coming out to be positive, therefore our assumed directions over here is correct. Now we need to find out R. R is nothing but square root of HA square plus VA square. And because this forms a concurrent force system representing equilibrium, this is the equilibrium actually speaking. This is the equilibrium in horizontal direction, this is the equilibrium in vertical direction, and this is the resultant equilibrium. That is equilibrium which will hold this system in equilibrium. So R equal to 18.55 square plus 20 square, that's equal to 27.3 kilonewton. So if at all we need to design this hinge over here, we need to design for this force, 27.3 kilonewton. Now find the support reaction at A and C of the truss loaded as shown. This is some kind of a structure which is used for roofing or railway purposes, okay, and connecting a gap. Anyway, it has a practical utility, and there is only one load acting over here. Probably it could be assumed to be wind load. Now, and reactions will come like this. Due to this horizontal force, this particular support should also suffer from a horizontal reaction, which will be like this. And I have placed it, we have placed it with a positive sign, that is HC going around, going horizontally right. HC horizontal reaction at C, vertical reaction at C, vertical reaction at A. Now we will say sigma Fx equal to 0, we will get HC. So HC is positive, minus 2 going like this, equal to 0, therefore HC happens to be 2 kilonewton. So sigma MA equal to 0. here we take the moment, it is 2, which is anti-clockwise like this, it will be rotating this the entire frame and in anti-clockwise direction, provided if we release this particular hinge. So the moment arm here till there, you can project like this in order to, if you are confused to find out the moment arm, you just project it along the line of action, and this is the perpendicular distance, and the perpendicular distance is given over here. So it is 2 into 3 and minus VC into 6. As far as this reaction is concerned, the moment arm is 3 plus 3 is 6 meters and minus 2 into 3. So minus 2 into 3. Therefore, we are getting VC equal to minus 1 kilonewton. Now, sigma Fy equal to 0, right? VA plus VC equal to 0. So VA equal to minus of VC, and that is equal to minus of minus 1. Just now we have got. Therefore, VA becomes 1 kilonewton. Now we will change the direction of this particular reaction as if it is going down. Now we can just find out very okay, a little understanding will tell us that the moment, external moment acting on the whole truss is 2 into 3 with respect to this point. And while the moment created by the reactions happens to be here 1 kilonewton going up, 1 kilonewton coming down, they are parallel and they are having a distance of distance between them equal to the span, that is 6 meters. Therefore it is 1 into 6, which is clockwise. So the reactions are creating clockwise moment while the applied load is creating anti-clockwise moment. Therefore moments will balance. Right. Now find the support reactions for the beam loaded as shown. So here is the beam which is loaded with uniformly distributed load of 20 kilonewton per meter as the intensity, and there is a ready-made concentrated moment acting at 1 meter from the right end or 4 meters from the left end. And we need to compute this since we don't have any representation for UDL whenever we take up the computation or analysis for support reaction, we need to convert that into equivalent distributed load. It has been well told earlier tutorials also. So it is 20 into 3, it becomes 60 kilonewton. Therefore this red arrow coming down will be 60 kilonewton and it will be exactly at the center of UDL, that is 1.5 meter from left end. Yeah, that is the total load due to UDL, equivalent concentrated load we call. So sigma MA equal to 0, we will apply, this is A, this is B. Now we have VB into 1 plus 1 plus 3, that is 5, VB into 5 anti-clockwise negative plus 20, the given clockwise moment. We will directly add this 60, that is equivalent concentrated load, into 1.5, that is also clockwise. We got VB equal to 22 kilonewton. And if we apply sigma Fy equal to 0, we have VA going up plus VB going down, going up once again. VA plus VB should be equal to 60, that is coming down. So VA plus VB happens to be 22, therefore VA, we got it to be 38 kilonewtons. So 38 plus 22 makes it 60. So with this we complete at least 6 problems of special interest, and in the next tutorial we will continue to find support reactions, of course little complex problems. If you have liked this video, please subscribe, and until I come with the 5th tutorial, bye and thank you for viewing this.